for the sequence. And then in that lesson, we determined if a given sequence is convergent or divergent. So this time, we will be going into what we call a series. Now, a series, let me just share. Okay, here. So, a series this time, may na nakita in other pa na mga um, other operations na bubuhaton. But before we go into a series, we will discuss two types of sequences that will be that will help us evaluate if a given series is convergent or divergent. So first is the arithmetic sequence. By the way, nakita hiton kuan PDF na siya share.
Yes, sir.
Nakikita
Okay.
sir pero
So the
gunti.
first good sige pa na ko unta. Okay. There. So the first one, first type of sequence is so there are many types of sequences. Ano, so I gave you last time different kinds of sequences. There at tuhira consider as either arithmetic or geometric sequence. Basta sequence na to ya, because when we say sequence, it's just an order of numbers. So in arithmetic sequence, may dagod hiya specific na what do you call this? There's a specific property to it. So we say that a sequence is an arithmetic sequence if each consecutive term has a constant difference. And then we can find the nth term of an arithmetic sequence using this formula. Pero we will not be focusing much on this. We will be focusing the second type. But I'll just need you to be familiar with this. So examples of arithmetic sequence, we have this one. So again, we can start our n from 1 up to infinity because again, we are concerned with infinite sequences. And the formula is given as 2n. So these are the even numbers. So you have 2, 4, 6. And you can see 4 minus 2, that's equal to 2. 6 minus 4, that's equal to 2. 8 minus 6 equal to 2. 10 minus 8 is equal to 2. So the difference of each consecutive term, meaning it magsapit na mga numbers, ira difference is a constant. So in this case, the difference is 2. And then we can also have this one. So our formula is given as 5n minus 1, and we want to start our n at 5. So substituting n to be 5, so 5 times 5 minus 1, that's 24. Then 5 times 6 minus 1, 29. Then 34, 39, and so on. And we will see here that the difference, 29 minus 24, that's 5. 34 minus 29, that's 5. 39 minus 34, that's 5. So the difference is also constant for each of the consecutive term. So we see here that ininhiya na d amo ini iton aton constant difference. Okay, so now we have the sequence that is of interest to us called the geometric sequence. So kung kanina, each consecutive term has constant difference, this time each consecutive term has constant ratio. When we say ratio, that involves division. And then the nth term of a geometric sequence can be found using this formula. The formula, if you search this online, iton iba may dadin I think n minus 1. That depends on how we start our n. Kaya iton iba, iton ira start iton n is equal to 1. But for our geometric sequences, we can start our n at 0. Okay, so constant ratio. Let's say we have this first sequence, 2 raised to the n. So 2 raised to 0, that's equal to 1. 2 raised to 1, that's equal to 2. 2 squared, 4. 2 cubed, 8. 2 to the power 4, 16, and so on. And ratio ko no, so magdi-divide kita. 2 divided by 1, that's 2. 4 divided by 2, that's 2. 8 divided by 4, that's 2. So, the ratio of each consecutive term, basta magsapit, i-divide mo nga ni, magpaparehas iton era mga quotient. We can also have this sequence, 3 to the power n over 2. And then again, substituting, we get um, these numbers: 1/2, 3/2, 9/2, and so on. Tapos we will see that um, the ratio here is equal to 3. Tapos nga diliwat, 3/10 to the n. So we start with 3, then 3/10, 3/100, 3/1000. And the common ratio here is equal to 1/10. So that is our, ininhiya na R, that is the common ratio or the constant ratio. So again, in the example number 1, that's equal to 2. Example number 2, that's equal to 3. Then example number 3 is 1/10. Okay, so now let us go to the main topic, which is infinite series. So what is an infinite series? It is simply the sum of an infinite sequence. So ininhira, panaad doon nato nitong hira. Pero this is infinite. So dir in hiya na human. So say kalahin add hasta dire ka na di ka gud mahuman pag inad. So what we want to see is magtitipakan to ba inin hiya ha positive or negative infinity, kay pwede man in mga negative, nagtitika negative. So when you keep adding negatives, then you will be getting negative numbers. So it might go to negative infinity, or it might be the case that's actually going to a certain number. So we will have some examples later wherein bisan infinite it imo giniinad na mga numbers, di rin natira maghihirayo nga ito sa ka number. So we can represent it as this. So if you're familiar, this is the Greek capital letter sigma. And sigma in mathematics is usually what is used to denote that we are getting the sum. So sigma, so the sum of the a's of n, wherein n is equal to 1 or starts from 1 up to infinity. But then again iton n, the starting number, it can change, it can vary, it can be 0 or it can be 1, depende kung ano iton given. So what we do here is simply we substitute the n's from 1 to 3 up to infinity. Okay pa so far? May the clarification so far? Hello?
None, sir.
Okay, sige, let me continue. So, because we are adding here, we will start with getting what we call partial sums. So, partial sums meaning mag-a-add ani kita tag gudti-gudti anay. Tapos, it can help us see if the sum will be convergent or divergent. So you might, I will give you in the problem set something that would say like this. You have the sequence in here, and then find the first partial sums of this sequence. So first 5 partial sums, or can be first 10, depending kung ano itong ginaaro. But for our examples, we will just be using 5 partial sums, and then we denote those by S1, S2, up to S5. So S1 basically is the first partial sum, S2, second, and so on. So ito atong sequence is 1/n. Now we have seen na ini na 1/n. Let me stop sharing. Let me have a different one. Okay, so we have seen that the sequence 1/n, n is from 1 to infinity. This is equal to 1, 1/2, 1/3, 1/4, and so on. Saman here, and mga numbers in our sequence na 1/n. Okay, let's go back. Okay. So, amit ato add. So, he 1 anay, ito at, so we will consider from n from 1 to 1, then n from 1 to 2, 1 to 3, sorry, what I did ma-edit is 1 to 4 and then 1 to 5. So kung 1 lang nga ni, so that's just the first number. So 1. Pag second partial sum natin kay from 1 to 2, so ang first term of the sequence plus the second term of the sequence. So 1 plus 1/2, that is 3/2. So from n from 1 to 3, so we will be substituting n as 1, then 2, then 3. So 1 over 1 plus 1/2, then plus 1/3. So when we add those three, it will give us 11 over 6. And then if we add from n from 1 to 4, then you will be adding 1 plus 1/2 plus 1/3 plus 1/4. That is 25 over 12. And then the fifth partial sum, if we have 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5, this will give us 137 over 60, and so on. So with this, ininhiya ng mga partial sums, we can't really say kung iton aton sum is going to a certain number or if it's going to infinity, kung magdidi na ko ulabay iton aton sum if we keep on adding numbers here. So partial sums sometimes is helpful, but sometimes dire kita makahimuhin conclusion about our series. So we will be using some theorems to help us determine if there is an actual number for the sum or if it's going to infinity. So we will be now looking at geometric series. So this is a kind of series that is obtained from a geometric sequence. An adihiya, ininhiya na 1 over n, this is not a geometric sequence. So we cannot use our theorem here. So what we want now to use are only geometric sequences. Miss Mabanto, paki-mute la or ako na ma-mute ta imo ha. Okay. So we will be looking at geometric sequences and then looking at the series of a geometric sequence. So here's the theorem. If you have a geometric sequence wherein r is not equal to 1, that is the common ratio is not equal to 1, then we can find the nth partial sum with this formula. So a times 1 minus r to the n over 1 minus r. So let's look at some examples. So we have seen kanina the geometric sequence 2 to the n. So this is 1, 2, 4, 6, 1, 2, 4, 8, 16, and so on. So if we will not be using the theorem, here is the manual computation. If pananglitan, this is the instruction, find the fifth partial sum. So to get the fifth partial sum, maagi gud kita ha, first partial sum, second, third, fourth, fifth. If diri ka pa maaramhan mga numbers nga imo sequence. Pero kung maaram ka na yung numbers nga imo sequence, then you can just directly do this. So 1 plus 2 plus 4 plus 8 plus 16 and so on. So we see that the partial sum, the fifth partial sum is equal to 31. But we can also use the theorem. So the theorem here, again, the nth partial sum is equal to a times 1 minus r to the n all over 1 minus r. So in this one here, okay, so in the formula that we have for a geometric sequence would be a times r to the n. Ngadahan aton sequence that was 2 to the n. So if you notice, the one that is being raised to the nth power is 2. So that means our a is equal to 1 and our r is equal to 2. So if we go to the partial sum, if we use the theorem, so a, amin hiya, 1 minus 1 times 1 minus an r. I mean, bibiling tapos an ikapira na partial sum an imo ginbibiling all over 1 minus r. So 2 to the power 5, that is 32. So 1 minus 32 is negative 31 divided by 1 minus 2, that's negative 1. So negative 31 divided by negative 1, we get 31. Now, you might say na masurusayon man ang mag-manual computation in Inhiya. Why should I use the theorem? Yes, the manual computation is easier if we are only using n that are a bit small. But if we use a big N, pananglitan, you will be calculating the 20th partial sum. So damo-damo ito ti imo gaan niya da. Tas you're not even sure sometimes if your sequence, the numbers that you are writing are correct. So if you use the theorem instead, then there is less room for error because you only need to find your A and your R and then substitute it to this equation, and then you will be able to find the nth partial sum. Okay pa so far? Any?
Okay pa, sir.
Okay, sige, no questions. Padayon anay kita. Okay, so let's have another example. The other geometric sequence that we had was 3 over 10 to the n. So let us find again the fifth partial sum. So if we have the manual computation, so we can do this. So this is the first term, 3 plus 3 over 10 plus 3 over 100 plus 3 over 1000 plus 3 over 10,000. And this will be, if we use improper fraction, then that is equal to 33,333 over 10,000. And if we use the theorem, so amo na inhiya. Our A this time, so let's dissect first this sequence, 3. The sequence is 3 over 10 to the n. Now for this one, the one that's being raised to n is this one, the denominator. Please notice this is equal to 3 times 1 over 10 to the n. Or that is, this is equal, that's equal. That is also equal to 3 times 1 over 10 to the n. So these are equal. I can write 3 over 10 to the n as 3 times 1 over 10 to the n. So this tells us that A is equal to 3 and our R, the common ratio, is 1 over 10. Okay, so let's go back. So using the theorem, again, we substitute A, which is 3, and our R, which is 1 over 10. So substitute. So we will be able to get the same answer, 33,333 over 10,000. So again, in Inhiya, mas complicated lagi lugod kitaon, but if we are going to use a bigger N, then it would help if we will be using the theorem instead of doing manual computation. Okay, so now we have this definition. So if the sum increases or decreases without bound, that means either it's going to positive infinity or negative infinity, then we say that the series is divergent. However, if the sum is actually a certain number, then we say that the series is convergent to that number. So we can get what it is equal to. So let's now look at a theorem which will allow us to get the, what they call this, the actual sum. So the theorem here states that a geometric series is convergent if and only if the absolute value of our R is less than 1, meaning this can be positive or negative, basta less than 1 iti absolute value, the common ratio. And the sum is equal to this, simply A over 1 minus R. So basically what you need to determine here is what is the R. Once you're able to determine the R, kita is the absolute value less than 1. If yes, then you can use this formula to find the sum. Okay, so let's now have an example here. So we have 1/2 to the n. So we want to find this sum, 1/2 to the n. So if we use partial sums, magagamit lang kita in partial sums here so that we see, basically, kung papahimon ko na kamo, papasolve ko na kamo, there's no need to use partial sums. I'm just including here the partial sums para makita niyo bagay may dahiya pattern kung ano't nahitabo. Okay. So if we have partial sums, so the first partial sum, so of course, 1/2 raised to 0, any number raised to 0 is equal to 1. Then 1/2 to the power 1, so that is 1, or the summation of 1/2 to the n is from 0 to 1, so that's 1 plus 1/2, that's 3/2. If n is from 0 to 2, and that's 1 plus 1/2 plus 1/4, that is equal to 7/4. If n is from 0 to 3, then that's 1 plus 1/2 plus 1/4 plus 1/8, which is 15/8. And then if n is 0 to 4, then that's this, and then that is equal to 31/16, and this is actually equal to 1.9375. Now, if you look at the partial sums, there's actually a pattern. Nga diton, second partial sum, that's 3/2. Pagtika nga dihiton aton S3, naging 7/4. Pagka dihiton fourth partial sum, this is 15/8. Pagka dihiton fifth partial sum, 31/16. So ano ito na relationship ni 4 nga ni 7 na dapat same ito relationship ni 8 can 15 nga ni 16 to 31. Can you see a pattern in the partial sums? Can anyone tell me what the pattern is on the partial sums? May nakam nakikita na
Sir,
pattern.
ito an.
Mhm.
8 numerator, nagka-times to pero may plus 1. Asya
8
ba?
numerator.
Bagat
Otro,
nagka-times to pero may daya plus 1. May da
plus 1 or minus
nagka-times
1?
to hiya. Plus 1 po, sir.
Ito numerator is times to hit denominator kung plus mo hin 1. Sakto?
Yes, sir. Ang numerator, sir.
Okay, sige, tama. So if we look at that, what is happening here is that that's 2n minus 1 over n. So I'm actually itong iyakuan. Bagan formula, iton mga partial sums. The partial sums actually create also a sequence in itself. So this sequence, if you actually evaluate if this is convergent or divergent, you will find that this is convergent. So using L'Hopital's rule, so the limit of n as the limit of 2n minus 1 over n as n approaches infinity, using L'Hopital's rule, I get the derivative, magiging 2 nga di, tas nga di magiging 1 as n approaches infinity. So this is just equal to 2. So the limit is equal to 2. So this, ang mga partial sums natin with this formula is actually converging to 2, meaning the sums, alawaray makita na akong solution, sorry. Okay, you have here. So the formula is, we can write it as 2n minus 1 over n. And then we can determine if this sequence, so bali, ang mga partial sums, ano to yan aton partial sums, we had 1, we have 3/2, then we got 7/4. Sakto ba ano ha? Let me check. Sakto. And then you got 15/8, and then 31/16, and so on. Ininhira na mga sequence, may da pattern, may da formula. Amin yan mga kuan, aton mga partial sums. So ang formula natin mahimo para hinin is this one. And this sequence, if we get the limit as n approaches infinity, we see that the limit is equal to 2. Meaning, ininhira na mga numbers, magtitika kadto ay ininhiya 2. Meaning, again, iton mga sum, bisan magpinadako kita hiton aton mga partial sum, magkuha kita S 100, 100 partial sum, 1,000 partial sum, very near to 2 iton aton makukuha na mga numbers. So we can illustrate that further using the theorem, Adhiana theorem, the theorem wherein it says na if our if the ratio is less than 1, the absolute value of the ratio is less than 1, then we can use this formula. So we can double check that by using the formula. So we have here, again, A over 1 minus R. Our A here is 1, and our R is 1/2. So 1 divided by 1/2, that is simply equal to 2. So we can either use, although adhiya, in inhiya na process, this is a bit complicated, but this can confirm our the theorem wherein we use the formula. So we see that the partial sums create a sequence with a pattern given by this formula. And then if we get the limit, check if it's convergent or divergent, then we are able to see that it is divergent and it is convergent and it is converging to the number 2, meaning the sum must be equal to 2. We verify that the sum is equal to 2 by using the formula. But don't worry, I will not be letting you find a formula for the sequence kay medyo complicated, makuri talaga niya na process kay not all sequences nakikit-anhin pattern. So if that is the case, what we do is simply use the formula in Inhiya. Okay, any questions, clarifications so far? Questions?
Pwede na yung pagkarohan ko manual computation.
Sorry, Seth, warek makakuhaan question. Ano to?
Ano yung mga sir kanina paggamit ang sum?
In here? Sorry, Morak, makunit imo connection. Puputo-putol ka. Pakiutro, ano to?
Hindi sir na amit akong gawin.
Okay.
Yung sa pagkakay. Para ko na makakuha.
Sa substitute lang nimo iton n. So, adhiya and first partial sum. So we use, because we are starting from n is equal to 0, so we start from 0 to 0, meaning we will be getting the summation. However, only for n equal to 0. So 1/2 raised to 0, that's 1. The second partial sum, we use n from 0 to 1. So meaning that's 1/2 to the power 0 plus 1/2 to the power 1, or simply 1 plus 1/2. So this is the second partial sum, 3/2. The third partial sum, we start from n equal to 0 up to 2. Meaning that's 1/2 to the power 0 plus 1/2 to the power 1 plus 1/2 to the power 2. How many 1/2 to the power 0? This is 1/2 to the power 1, 1/2 to the power 2. Add them all up, you will get 7/4. Fourth partial sum, same process, n from 0 to 3. So 1/2 to the 0 plus 1/2 to 1, 1/2 power 2, 1/2 power 3. Amo ininhira. And then fifth partial sum, 1/2 power 0, 1/2 power 1, 1/2 power 2, plus 1/2 power 3, plus 1/2 power 4. Add itong haratanan, we get 31 over 16. And it so happened that ininhira ng mga partial sums may dahira bagahin kuan, may dabagahin pattern na na-come up. But not all partial sums will have a pattern even if it's a geometric series. So, kunwari nga ni pattern, tapos ito instruction masring na find the sum ininhiya. Then madiretso kala na i-apply nimo an theorem, which is this one. Because we are able to determine that R is equal to 1/2, and of course 1/2 is equal to 1. I mean, is less than 1. Because again, going back to the theorem, it says that it is convergent only if R is less than 1. So that is the first requirement. Dapat R is less than 1. If R is less than 1, then you can use the formula. But if your R is not less than 1, for example, ininhiya, R is equal to 2. Tapos kita ito imo numbers here. 1, 3, 7, 15, 31. Nagdidinako. Hasta magdako na nga iton imo and dinhi, it imo pananglitan, you are looking for the 1,000 partial sum. That is a very big number. If you look for the 10,000 partial sum, that's another very big number. So your sums are increasing without bound, so it is going to infinity. So that means that this is divergent, meaning diri naton magagamit adihiya na formula and ininhiya. Diri magagamit because R is more than 1. So the only way that you can use this formula is if R, the absolute value of R is less than 1. Okay? Na klaro na to, Seth? Seth?
Yes, sir. Nakakuha naman.
Okay,
Yeah.
sige. Anyone else who has
Thank you.
a question or clarification? Waray na question? Sige, kay we will be looking at other examples. Let me kan anay ha. So let's have some other examples. Okay, here. So here are some other geometric series. And then we are looking for the sum. So for example, our geometric sequence is given by this. So clearly our A is equal to 2 and our R is 1/3. So 1/3 of course is less than 1. So we can find this sum simply by putting it into the formula, and we get that the sum is equal to 3. We can also have this one, summation of 0.99 to the n. 0.99 of course is less than 1. So we can use the formula. Substitute lang adi. And this is the answer. Now, if your geometric sequence is this 1.01 to the n, of course 1.01 is already more than 1, so not less than 1. So we cannot use the formula. So diretso kala mastering na the series diverges or the series is divergent. So no calculation anymore, or ma-justify kala na since R is not less than 1, or you can say since R is greater than 1, then the series is divergent. Then you also have these other formulas, other sequences. And these are the togiton. This is the sum 1/6 using the formula. So iton medyo magiging challenge la iton niya din is to make sure that your calculation kay mga fractions usually since mga fractions in Hera, then it will be a bit challenging. Okay, for this one here, the first term, the a na gingamit is equal to 1/9. Kaya no 1/9 because it gave us here that our n is equal to 2. So if n is equal to 2, then that is 1/3 to the power 2. Then that means that this is 1/9. So our a is 1/9. I will not be giving you anything like this. So amo lahat to mga sugad lain inhera na mga um, geometric series na mga medyo madali na ma-determine if convergent or divergent. Any questions on those other examples? Clarifications? Okay, let me go on and stop the presentation. Okay, so ganito at bubuhaton niya. I want you to try solving, determine if the given series converges, and if it converges, find the sum. If it doesn't converge, then justify kay ano hiya divergent. Please kuan bali pag try ko pag-solve nga daha iyo, of course in a piece of paper, or if you can if there are some of you who are using a laptop, kung nagla-laptop ka mo, you can try solving in our Jamboard. I'll give you the link. Ayan ang chat. In the chat box, I put there the link for the Jamboard. Pwede ka mo nga magsurat-surat, pero magkukurya na da ka mo. So, I want you to try and solve. Ano to? Try and solve this in first two anay. Ay, medyo makura ito. Inilaan na number 1. And please take note that the n here is equal to 2. So please determine if this is convergent or divergent. Try solving in your tapos those who have a solution, i-point na let iyo camera nga dahiton iyo papel. I wait, sorry, alas 3 naman. Sige, we will just have our problem set na la and we will continue our discussion next week. Next week, we will be having our class on Wednesday at 1 o'clock. Are you available that day? Wednesday, alauna?
Yes, sir.
Okay.
Yes, sir.
Sige, kay. Uh, there will be an accreditor who will be observing the class. So, ma-join hiya hiton Google Meet. So, mag-observe hiya. So, just be your usual self, but please kuan magpapakyanhan baton yan. Tapos just like the usual kung may mo diri na naintindihan, you can ask, but if possible mag Filipino or English kay ito nago-observe diri taga dinhi ha Leyte, so may diri makaintindi ba. But if di good kaya kung waray-waray gud pagpakyan na waray ket may himo. Pero if possible pag Filipino or English la kamo next week. Okay?
Yes,
Sorry.
sir.
Sir.
Sige. Any other questions or clarifications?
Sir, napasa mo na ba na slides?
Ha? Anay, Maridet. Anay ha.
Yes, sir.
Ano to, Paulo?
Sir, napasa mo na ba na slides sa group chat?
Waray pa.
Sige,
Nagsasan
sir.
kayo niya.
Okay, sir. Thank you.
Okay. Maridet, ano to, may daka ginyayakan?
Awaray, sir.
Kadakot busis. Okay, sige. Anyone else? Ay, napagtawa. Pakimute na. Bakit yung busis? Napabungol. Anyone else was a question or clarification?
Sir, pwede po kami makaaro ito na PowerPoint?
Yes, definitely. I'll be sending this to you.
Sige, sir. Thank you.
Welcome. Igsasan ko gyapon iton kuan YouTube link later. Niya na nagabi kay mahina it internet nga dia office. Kailangan to ka balay para makurkusog pag-download ngan pag-upload sa YouTube. Sige, if there's no other question or clarification, let's call it a day. Thank you for attending this class. Keep safe, everyone. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.